Hi everyone! Today, we're going to discuss about method of joints for analysis of simple truss. The free body diagram of any joint is a concurrent force system in which the summation of moment will be of no help. Recall that only two equilibrium equations can be written, and these are the summation of forces on the x-axis and the summation of forces on the y-axis, which are both equal to 0. This means that to solve completely for the forces acting on a joint, we must first select a point with no more than two unknown forces involved. This can be started by selecting a joint acting on by only two members. Second, we can assume any unknown member to be either tension or compression. If negative value is obtained, this means that the force is opposite in action to that of the assumed direction. Once the forces in one joint are determined, their effects on adjacent joints are known. We then continue solving on successive joints until all members have been found. So here's a sample problem for a deeper understanding on the method of joints for analysis of simple trusses.
Hi, today we are going to solve a problem about methods of joints, and the problem is to compute the force in each member of the truss. So here's the figure. So remember, when you're solving methods of joints, remember to draw the free body diagram and to assume whether each member is in tension or in compression. So in this problem, I would probably start on a point where there are less forces acting upon it. So I would either start at A or E. So for this problem, I would start at A. I would get the reaction of A. And by doing that, I will have to get the summation of moment at E. So summation of moment of E is equal to 0. So RA, Y is positive, clockwise direction, and times the distance, 20, counterclockwise, so 2,000 pounds is negative, times the distance, 5 and then 10, 15, 3,000 counterclockwise again, the distance is 5, minus 4,000 times the distance, so 10. So that will equal to 0, that will give me RA is equal to 4,250 pounds. So after that, you could already get the member AC and member AB at point A. So at point A, like I said earlier, we should do first the free body diagram. So point A, this is point A. So I will assume that AC here, AC is in tension. So the direction of my force is going to the right. This is AC. And I will label it tension. And then AB here, I will assume that this is compression. So meaning the forces is going inward. So from point A, my force would be going to the left. This is AB, compression. And then my RA, up, so RA. So now I could get the summation of forces at Y. So that would be negative AB sine, and the angle, this is 60 degrees, 60 plus RA. And that will give me AB is equal to 4,907.48 pounds. AB is in compression. So next, summation of forces at X, so equal to 0, equilibrium. I will have negative AB cosine 60 plus AC is equal to 0. So the value of AB, that would be, I would transpose this to the other side, so that would be 4,907.48 cosine 60 is equal to AC, and that will give me the answer of 2,453.74 pounds in tension. So now I have the two values of the two members, so that is AC and AB. Now I could get another member. So I would like to start, I would go then next to point B. So at point B, same thing, I would draw the free body diagram. So at point B, there is 2,000 pounds. And then there is BD, which I will assume BD is in tension. So meaning it will go to the right tension. Label it tension. And then here, BC, also in tension. I will label it in tension. So BC, tension. And then another one is AB, which is compression. So, like before, summation of forces at Y is equal to 0. So, negative 2,000 plus AB. This is 60 degrees. Okay. This is 60 degrees also, 60. Equilateral. So, AB sine 60 minus BC sine 60 is equal to 0. So, I would substitute the value of AB and only AB, to get the value of BC, transpose to the other side to be positive, and that will yield to an answer of 2,598.08 pounds, and BC is in tension. So, let's do the summation of forces at X. I will do it here. Forces at X is equal to 0. And that is AB cosine 60 plus BC cosine 60 plus BD is equal to 0. So that will give me, for me to be able to get the value of BD, I will transpose this 2 to the other side, and that will give me a negative answer. But it's okay, since the only thing that will be affected is the direction and not the value. I will change that later, because it is important for you to use the negative value all throughout if BD will be used again in other members, so that you won't have a wrong final answer. So just let that stay. I will change that later. So let's move on to point C. I start at point C, since there's given. So like before, free body diagram, point C, there is 4,000 pounds. 4,000 pounds. And then at point C, I will assume that CE is in tension. So my direction is to the right, CE, tension. And then CD, this is CD. I will also assume that this is in tension. So upward to the right, CD in tension. And then BC here, this is in tension, BC. So here, BC tension. And then AC, going here. So this is 60 degrees, 60 degrees. So again, summation of forces, Y is equal to 0. So CD sine 60 plus BC sine 60 minus 4,000 is equal to 0 will give us the answer CD is equal to 2,020.72 pounds. CD is in tension. So next, summation of forces in X. CE minus AC plus CD cosine 60 minus BC cosine 60 is equal to 0, which will yield to an answer of CE is equal to 2,742.42 pound CE, which is tension. So now I already have this, and this. So the only member that I don't have is DE. So I would probably get DE at point D, since this has no value, so it's better to get at point D. Same, do the free body diagram, so 3,000 pounds. DE, I would assume DE to be in compression, so my force would be upward to the left, DE, in compression. And then CD, in tension, and BC, in compression. So again, this is 60 degrees in respect with the horizontal axis. So summation of forces of Y is the only way for me to get the value of DE, and that would be DE sine 60 minus CD sine 60 minus 3,000 is equal to 0 will give me the answer of 5,484.82 in compression. So, I will now simplify all my answers, the correct answers. So, AB, I got a positive value, so this is correct. AB is in compression. AC, I also got a positive value, so this is correct. BC, I also got a positive value, so this is correct. And then for BD, since a while ago I told you that it doesn't matter if you got a negative answer because the final answer, this value will not vary. So here in BD, since you obtain a negative value, it's okay. There's no problem with that since the value will not change, only the direction. So what I will do is to change that to positive and change BD, which is in tension, into compression. So that is the correct answer. So BD in compression, and then DE positive value, so that's also correct in compression. CE positive value in tension, correct. And CD positive value, so that's correct. So that is how you solve methods of joints using summation of forces and summation of moments.